Hello and welcome to our latest roundtable, Adopting, Implementing Automation. I'm Jake Kaufman, the Associate Editor for the Manufacturing Group at GIE Media. We have some of the heaviest hitters in the industry ready to tell you the best approach to implementing automation and where to start. We'd like to take this time, though, to thank our sponsors first, HIGH QA Inc., SCHUNK, and THK. SCHUNK, the family-owned company, is a worldwide leader for equipping modern manufacturing and robot systems. More than 3,500 employees in 9 plants and 34 directly owned subsidiaries ensure an intensive market presence. With more than 11,000 standard components, SCHUNK offers the world's largest assortment of gripping systems and clamping technology from one source. Due to the digitalization of the portfolio, users can plan their processes efficiently, transparently, and economically. In addition, they benefit from the comprehensive application knowledge surrounding tomorrow's innovative manufacturing. HIGH QA is a leading provider of integrated manufacturing quality management software solutions. They are for any size company in all major manufacturing industries. Inspection Manager, built on the HIGH QA 360 platform, optimizes and automates the entire quality process, creating a seamless partnership and collaboration with supply chains. It provides quality insights above and beyond pass-fail, eliminates human interpretation errors, and reduces quality control bottlenecks. This ensures products meet specifications, are delivered on time, and comply with applicable standards. With extensive industry experience, HIGH QA keeps its customers and partners at the forefront of quality 4.0 and manufacturing technology. And our final sponsor is THK, who wanted to let everyone know we appreciate the opportunity to be a sponsor for the edition of the Automation Roundtable and to be part of the prestigious group who will help lead factory automation into the future. We do regret not having one of our linear motion experts available to speak with you today. By way of this statement, THK would like to reinforce our direction on factory automation as it applies to our company's vision. For the past 50 years, THK has provided the highest quality motion products to many industries. We have seen many changes over that time and expect to see many more as the speed of technology enables changes in processes in many industries. THK has grown globally because of our ability to listen and understand the needs brought about by this type of change in automation. Recently, THK has introduced the Omni Edge. It's our proprietary predictive maintenance solution to the North American market, and continue to work with strategic partners in producing necessary components for robotics and to further the development of artificial intelligence. Beyond being a globally recognized manufacturer of linear motion components, THK prides itself on offering innovative services in the areas of product integration, engineering, and mechatronics to be able to assist customers in bringing their ideas from concept to reality. As many companies have started to reimagine how their businesses would automate to meet future needs and demands, THK will be there as they have been for 5 decades, providing our expertise and our proven high precision components, most of which are produced here in the United States at our world-class facility in Hebron, Ohio. We would like to extend our thanks to GIE Media for the opportunity to participate along with this distinguished panel. Now, speaking of that distinguished panel, let's get ready to know these panelists before they speak. So we will begin with Sam Golin, as he is the founder and CEO at HIGH QA Inc. Sam has helped guide HIGH QA from the entrepreneurial stage to the industry presence it is now. His expertise in business development, product positioning, market strategy, and team building allow HIGH QA to grow continuously. He has over 25 years of experience as an international executive and has founded, co-founded, and managed 5 different companies within CAD/CAM, PLM, CRM, and knowledge management. We will also be joined by Thomas Reek, Vice President of Sales and Automation at SCHUNK. Tom has more than 25 years of workpiece gripping and handling experience. He graduated from NC State University with a BSEE in electrical engineering and began his career with SCHUNK in 1994 as an applications engineer in the early years of the company's launch to the United States. Tom went to pursue new challenges in the field of automation, gaining experience in vacuum technology and pneumatics. He rejoined SCHUNK as a regional sales manager covering the Southeast United States with a goal of growing the company's automation products through a combination of direct sales and a network of industrial distribution partners. Tom's career has continued to grow and evolve at SCHUNK. He has served as director of sales for the Eastern States before being promoted to his current role as vice president of sales for the entire USA. Today, Tom leads a team of motivated professional territory sales managers dedicated to serving customers and making SCHUNK the recognized leader in workpiece handling technology. Now that we know our speakers, let's get down to the discussion, as we will now be joined once again by Sam and Tom. And we will begin today with Sam, as we would like to thank you for your time and wanted to get started with, there are many motivators and factors to consider when implementing automation. So what is the best way to approach automation in order to be successful?
Big question. We can talk about it, I think, 3 days in a row, but let's do it a little bit shorter. Well, there are many motivators to apply automation. I think the basic one is obvious. Let's make more money with less cost. This is good motivation, but the main driver, if we kind of drill down a little bit, what motivates organization to invest in automation, I would call it competition. And of course, ROI, but ROI became secondary, as more important is not to lose deals if you still plan to stay in the business. Of course, there are other motivators to do it, but they are kind of considered as sub-motivation or sub-motivators, but with less impact on decision-making to apply automation. But look, the good news is that manufacturing industry is in amazing growth for at least in the next decades, if not longer than that. With that being said, looking into what happened in the manufacturing industry, OEMs are applying heavy pressure on suppliers with multi-factors. Of course, short delivery time, of course, lower cost, and high quality with growing changes and actually updating regulation, increase all the time, requirement changes. And it's not today just providing parts. It's also the budget required to do what we call packaging or submission package. Now, when you create the parts or make parts today, the requirement of APQP or PPAP and whatever related industry name it is require a lot of effort. We have customers that before they applied what we call automation used to say that the ratio between making a part and preparing a package, PPAP, very known, is 1 to 5. That means that every 1 hour we invest in manufacturing, we invest 5 hours on preparing paperwork. And that's very painful. Just to give some perspective on what happened in the industry in the last 2-3 decades, the good news comes challenges, as I mentioned earlier. But when we will look into the numbers and what happened in the manufacturing industry, I think it will be clear. If we're looking into the aerospace industry, and when Boeing started with the 737, let's take it to there, the total parts in 737 was 400,000. I'm going to jump over multiple model and go to the last one, 747-800 series. Guess what? 6 million parts. That's crazy. Someone needs to make them, right? If you look into the, the standard car that we drive today, 30,000, 40,000 parts. You go to hybrid, 60,000 parts. We're going to autonomous car, we're talking about 90,000, 100,000 parts. Someone needs to make them. And I'm not talking about the medical industry, the defense. Look, the manufacturing industry is booming, no question asked. By the way, iPhone every 20 seconds. Someone needs to do it. So looking into this positive, scary number of parts that is growing, it's clear to us that parts, it's not just make them, it's those parts are getting dramatically smaller with much tighter tolerance that will require different technology and automation to make them on time, on budget, on quality. And all of this now require packaging. I don't see medical parts that not inspected 100%, and then all the documents needs to be created with the parts. No documents, I'm not taking the parts. So it's a huge burden on the supplier to make them right. Well, I will conclude this answer by quoting one of a very strategic customer that he's tier 1 supplier for the automotive and the aerospace industry. He used to say the following: my customers always ask for a good price, high quality, and quick delivery. Before applying automation, I told them you can get only 2 of the 3. You cannot get them all. Applying automation, you can talk to them today, they can get them all. So automation is a key, but probably we'll expand more in the upcoming other questions that we'll have. Thank you.
All right. Well, thank you very much, Sam. Sam and Tom, thank you very much for meeting with us today as well. I would like to ask you the same question. So what is the best way to approach automation in order to be successful?
First, thank you for having me here. It's great being, it's an honor being part of your webinar. And to be here with Sam, I thought his answer was amazing with especially the statistic about the aircraft. That really blew me away, and to put it into perspective about how much excitement and opportunity there is and the need for automation. It's so wonderful. What we're seeing now because of that as a component supplier is that many companies are going out, they're having this need to automate often for the first time. And that it's a challenge, it's daunting when you're first doing that. So when you're approaching automation, having not done it before, especially in a case where you're manufacturing parts with tight tolerances and the packaging and all the things that Sam had described, you have a pretty big job ahead of you. So what we've been advising to companies that approach us is to not just look at where you're going to get your biggest payback for your investment, because that is important. Surely that's important. Take your first projects and look at those that you have your fastest and best chance of success early. So when you go through, look at your process, and I'll give you an example. We had a company reach out to us about 2 years ago, and they started buying cobots, and they knew they wanted to automate. They made an investment in cobots, and they had a dozen places in their plant. It was a large metal cutting shop, and what they were looking, they had about a dozen projects in mind, and one of the ones that had the biggest payback, it also had the most challenges in front of it. And we worked with them really hard to take the most simplest project that we could find out of the 12. And that would also have payback as well. But even though that it was simple, that it would still give them a lot of experience and knowledge that first time that they can apply to the next project and the next. And we strongly urge that when customers or when companies are thinking about doing these things, that they look for those, even though they're not going to be the biggest things that are going to press management the most. Look at the smaller ones, make them successful. And the fact of the matter is, with many of the jobs that, or many of these types of applications, oftentimes there's some root of the application is exceedingly difficult. You're holding a part that had never been automated before. The part wasn't designed ever to be automated. If we look at other industries that heavily use automation now, when designers design the workpiece, they actually designed it with the manufacturing process in mind behind it. That's not a manual process. And so a lot of times when now customers are new to automation, they have all these disadvantages because they don't have this infrastructure behind them. So it's only fitting that I'm speaking with you today from a part of our organization, SCHUNK, that we have designated for actually testing the root parts of material handling or automation. So we call it our collab. And right now it's empty, but you can probably see behind me there's some robots and other tools. And this is a way that if a company is looking to take a part that's difficult to grip, or it's needs to be deburred in some special way, or you need to put an O-ring on a part, the best thing to do a lot of times is make sure that we can get the confidence that the process that you're trying to do can be done. And then once you've built up that, then you can design the rest of the automation around that. So that's also something that's really important. Make sure the core of what you're doing is practical and you're capable of doing it. And then doing all the secondary processes that support it comes a lot easier.
All right. Well, thank you very much, Tom. For our next question, we'll go back to Sam. And how can automating your production help reduce hiring and training costs, as well as the uncertainties of the labor market?
Well, it is definitely can reduce hiring, as automation can replace labor. But in many cases, you will plan for more throughput when you apply automation. So I think the idea is not applying automation and let 10 people go and say, well, I have now more capacity for throughput. And as I mentioned earlier, once you apply this automation, you become more competitive. So I would like to do more. So I may add another line and I may use the people to do more, I would say, efficient job than labor that they used to do yesterday. Yes, it required training, but that's another topic, probably maybe discussed later. But here is the main achievement when we apply automation. It's not like having 5 access machine doing a job automatically instead of 3 access machine that you have to do 1 or 2 setting before the part is ready. When we look into automation, it's more on the acquiring knowledge, if you will, because today, in some action that's done on the shop floor, it's made by very expert employees who has their knowledge in their brain. And there is no great tool to take it out from them, because when they get retired or going to another job, then you're kind of stuck because they know everything. So the idea about automation, and again, automation has a very large context on what it's consists of. But the way we look into automation is not just about the machine that does the job automatically without labor, is who gives the order to the machine to do it this way, and where this data goes after that, and how I'm going to utilize the data for the next job. So all of that, actually, when we talk about automation, it's process, it's technology, and the whole idea when we talk applying automation, it will be recorded in a database, not just as one piece of a process. Because at the end of the day, you get a purchase order, you need to get the part on the truck to your customers. And you need to look into the entire process and not just one segment into it. So just trying to conclude it, automation, yes, will reduce training time, because instead of training, human being, then the machine will do the job. But again, we would like to have this knowledge translated into automation. And that's the key component when we talk about automation or reduce hiring or training costs. It has much larger context than just this narrow definition.
Thank you very much, Sam. Now, Tom, I would like to ask the same question once again to you. How can automation or automating your production help reduce the hiring and training costs, especially in an uncertain labor market?
I think if you're talking about labor, that the one thing you can't get, that really always has to be brought up is there's a still somewhat of a fear in the general public about automation, particularly surrounding robots and job killing, job stealing. And so I think it's important that we talk about that. I looked up last night, the Bureau of Labor and Statistics shows that at the end of 2022, there were nearly 900,000 manufacturing jobs that are not filled, that are open right now, that are not filled. And this is at a time where you're seeing Q3 and Q4, according to A3, were record sales of robots in 2021. And so just during the times of the market where sales of robots are skyrocketing at the same time, we're also seeing very high demand in the labor force that's not being met. It's not being met. We don't have enough going into the labor market. And so, it's important to see that and to know that companies that are investing heavily in automation, are doing well and thriving and actually able to hire on other employees into the types of roles that people want to do. People want to be able to go into a position where they are adding value to the organization, where they're being paid well to do it. Conversely, if we look at manufacturing, even when I was growing up, manufacturing was not something that people wanted to do out of school. I wasn't particularly interested in manufacturing out of school. When I thought of it, I was thinking of a dark room with people putting things together, people picking up parts out of furnaces, or cutting up meat in poultry plants, and all kinds of terrible things. And today, manufacturing is exciting, and we're seeing even just yesterday, I talked to one of my colleagues at SCHUNK that went to a local job fair at NC State University, and he had so many great conversations with students that were excited to talk about graduating in engineering and actually wanting to go out into manufacturing. So it's wonderful that we're seeing that, and that we can close those skills gaps that are in front of us. And automation is just one tool that's allowing us to be able to move forward and to be able to to meet the demands of the market, but not doing it in a way that is harmful to people.
Okay, now we actually do have a question from the audience when it comes to the training. So they were wondering, is the training going to include maintenance of the machines, as necessary programming needs to be integrated when it comes to the different machine tools, the cobots, the measuring equipment, etc.?
So I can start that off, unless Sam, if that's okay. So often what we see, because I work more in the physical side of automation. Sam is definitely the expert when it comes to data collection and those kinds of things. What we find from SCHUNK is when a piece of equipment, automation equipment, is built and sold, when it goes to the end user, there's usually part of that package is including some type of maintenance. So if you're buying a robot or you're buying a cell, that there's a lot of training that goes involved when the people that that start up the cell and that is provided is offered by the provider of that automation. And that's also good, because oftentimes what happens is a plant, when they buy that first cell, their in-house people now become experienced. They become robot programmers and they get expertise, and it allows them to then become even more independent. So on future projects, they can take on more and more responsibilities for themselves once they get those first machines and they get training. And we've been seeing another cool trend. Some manufacturers of automation are even doing remote work, where they have ways that they can monitor the machines and they can help coach the local people through problems as they happen, so that they can overcome obstacles in real time as companies are trying to learn to be able to cope with this new technology that they're working with, what they're working.
Thank you very much, Tom. Yeah, Sam, is there anything about the training as far as the maintenance of the machines that you would like to add on to what Tom had said.
We don't have machine that we sell. We support machine, different machine all over the manufacturing industry, which is more on the second part on the automation, which is we talk about data collection. But we are not handling any hardware, if you will.
Okay.
We are a purely quality management software company, and I will refer into it probably in the next question or so, I believe.
Okay. Yeah. Sorry about that, Sam. So yeah, what this question is to you then. What are some of the challenges that should be considered before you begin automation?
It's nice that it's ended before automation. I'll share kind of a story from my hands-on experience coming from the manufacturing industry. I mean, the whole HIGH QA didn't start from that I am a QA person. By all means, I wasn't. I'm coming from the manufacturing as a co-founder of CAD/CAM company, so I spent million years on the shop floor. And we did a lot of what I call lean manufacturing, from manufacturing company, job shop, from 30 people to 3,000 people. And in many places when I talked about, I call it quoting from delivery. You get quote, request for RFQ or RFI. What is in between when you get a PO until the part is on a truck going to your customers? So we look into the process from A to Z. We recognize or identify bottlenecks with the team. And every time that I spoke about quality, it was like, this is something that it's a big bottleneck. I said, what is the bottleneck? And I was said, like, go and spend time there and you will tell us what is the bottleneck. So I went into a quality department. I saw a very nice CMM machine. I didn't know even the name at that time, but running and inspecting part and all kind of inspection tool, much more than NC machines. There are thousands inspection tool and maybe about 5 brands of NC. But what caught my eye is somebody sitting and bubbling print by hand, like doing circles on a piece of paper or a drawing. And I wondered, what is that you do? And he said, oh, I'm preparing it for inspection. But I said, I was on the shop floor, the part is ready. And he said, no, in 2-3 days, I will be able to finish it. And then it will go to inspection, this big machine that runs and inspect part. And I kind of realized that you investing in all kind of technology without seeing the big picture, and you may have amazing machine or amazing automation in one place, but actually you move the bottleneck for another place if this is not really automated. So what is the value of automating one segment of your process, okay? So I think the biggest challenge is not to rush and buy or invest in any technology, either machine or software, before seeing the complete picture from start to finish. And I mean, when I'm referring to start to finish, from my point of view, is once, as I mentioned, you got a purchase order, or either your ERP generate job number, what happened all the way until the parts is on the truck, on the design, manufacturing, and quality. Because you may have amazing machines and your part is ready like in no time, but you have the quality behind like 5 days or 5 weeks, still making inspection and packaging and paperwork. So what is the value? So you have to look into automation as a whole, because when you deliver, you have to see what is in the package. I'm not against automation, don't get me wrong. I'm all full and this is what we do. But look into the entire picture before you jump and invest money on automation. And it's better to try to keep your all components or all your department in the same line, so you will get to the finish line at the same time, because you can have, it's easy to invest in machine. It's easy to invest because it's very attractive. You see them running in trade shows. It's like, oh my God. And then somebody's still bubbling print by hand and it will be your biggest bottleneck and you cannot deliver your part. So that's when we talk about automation or challenges in automation, you should see the entire process. When we are applying, when we talk about automation as a quality management system, and you can look into this industry, in many places, you may find between 5 to 15 different, I call it applications, software packages, Excel, you name it, it's there. So in order to complete a job in quality, you need to utilize multiple solutions, if you will. Coming from the manufacturing industry, we have CAD/CAM. I'm designing the part and I'm cutting the part with the same software. Why should I jump from one place to another? Then what we say, we have a lot of data, but you don't have information. So you lose all the connection. So where automation will come in place, you cannot. So the idea is to consolidate all those activity in one cohesive system, have it in a database. And from that point, you can go into the finish line together and sometimes even faster than manufacturing. But you have to look into the entire picture before you apply any automation.
Awesome. Thank you very much, Sam. Now, Tom, over to you. What challenges did you guys have to consider before automating?
Well, I like Sam's answer so much about having to know the big picture and being able to know the whole process start to finish. So I'd just like to build on his answer. I thought it was so fitting. If from the hardware side and the physical side of automation, I think about the entire process as well. Often we'll see a customer will come to a show or they'll decide that they want to automate and they'll go out and they'll buy a robot, but it's really more than that. Oftentimes the robot is only one part, it may even be a central part of the process, but there are a lot of pieces and parts that surround that process that have to be addressed that you need to be able to look up at front. So if we take an example of a machine tool, for example, a part has to be machined. You have raw parts coming in on a cart or a conveyor or some other way. And on the end, maybe right now it's manually loaded into multiple operations on a single CNC machine or multiple CNC machines. Comes out the other end as your final work piece, and you do your gauging, your testing, your quality, and on to your next processes. When you go to automate that, you have to look at the whole side of it. You have to look at, all right, how am I going to make my infeed suitable so my robot can be able to reach that part? How can I reach that part in an orientation where I can grip it and then be able to insert it into a chuck or to a vise? And then when I insert it into my work holding fixturing, is it a manual fixture today, or is it an automated fixture? Because if it's going to be automation, it has to be an automated fixture. So on a lathe chuck, it's probably cut and dry, but on a vertical mill, for example, you need to think about the automation on the machine table, just not only the automation on the robot arm. Then you also have to think about robot reach, getting in and out of the machine, be able to position the part correctly, be able to take it from that first operation. Think about what happens. You put it in as a raw material. It's a block, a cube, a rectangle, a cylinder. When it comes out, that part looks entirely different now. So how am I going to handle that part when it comes out of the machine versus when it went into the machine? And then when I take it out, how am I going to outfeed it downstream to the next process, wherever it's going next, to be heat treated or ground or whatever it is that's coming up. So until you know all those answers start to finish, you don't want to spend a whole lot of time just thinking about the robot loading the part into the machine. You want to be able to know the whole picture. And I think a good thing, which can be helpful if a wise investment a lot of times, is to have somebody on staff or even a consultant that can come in that has that experience, that knows all those questions to go in advance. It's a little more of an investment by having that, but it can get you going so much faster because you can get those things sorted out much quicker and you have less stumbling blocks, so that first investment will pay off and you can move to the next one and to the next one.
Awesome. Well, thank you very much, Tom. That takes us to our next question. When it does come to automation tools, best support the changing of volumes? Because, sometimes you won't have as many things being produced at once. You also might have to go into a mixed operation. How does automation help with that? I'll go to Sam first with that. Sorry.
Okay. I think this is kind of an opening another can of challenges, if you will, from our perspective. Because when we talk about production and we talk about quality and inspection, how automation can apply in this, because here is a challenge, and I can give you a real use case without mentioning name, of course, but we have a very large medical customer, and they are unbelievable product they have. And they are not making even one parts. They're having like, I think about 80, 90 suppliers outside. And they are making for them all the parts. Now, those suppliers are making those parts are very unique parts, very unique operation, very unique technology. And when a supplier needs to give them like 1,000 parts, they cannot plan on getting those 1,000 parts at the time they order it, like said, oh, we need it in 2 weeks, 1 month, whatever the case. So the supplier send them like every time that they have like a batch ready, 10, 30, 50, 80, whatever it is, they're happy to take. But now comes this the challenge. When they design the part, and then that's kind of, I think, emphasize the all-in-one system instead of doing everything in different pieces. Now it enables them to create the requirement on those incoming parts from customers based on quality requirement. It's AQL, okay, acceptance quality level. But they create this AQL based on a batch of 1,000. Now they are on the shop floor, and now incoming parts coming 30. Yesterday, I'm kind of playing here. Yesterday, when they got 30, somebody needs to recalculate again all the AQL based on this 30 instead of 1,000. It took them days. Today, when they're coming in, they push the button, we have 30. The system, based on the planning at the beginning, immediately calculate. It takes seconds, and now they can inspect those 30 based on. So the ability to provide, and this is again talking about automation, talking about seeing the whole process, how to eliminate bottleneck. When we sat with these customers, when we talked about process from A to Z, now those 30 or 50, whatever came in this batch, can go very quickly to their customer, which they are hospitals, okay? Yesterday, or whatever before the automation, it took them a couple of weeks before they can inspect them and do it in the right way. So I think the idea about automation in manufacturing has, and again, I'm talking about medical parts, aerospace parts, which most of them are smaller, high tolerance, tight requirement, tight regulation, let alone packaging, PPAP and stuff like this. By the way, PPAP that started in the automotive industry now applied in medical and aerospace. So the idea is that even if you have, we call it dynamic AQL, if you will, enables you to handle manufacturing capacity or volume change like immediately. So kind of an example that I wanted to share.
Perfect, Sam. And over to you, Tom, then. Yeah, what are some of the tools that work best when it does come to, changing the volume levels or the mixed use of the different machines and operations throughout the day?
I think if we back up and we look at automation, starting really coming into practicality 30, 40 years ago, it was set up, the industry was set up around high volume production. Automotive was clearly, like Sam said, it was clearly the front runner in automation. We think, we have customers today that make fuel injectors and camshafts, crankshafts, valves, and other components, and they're pushing them out the door in thousands of days, sometimes hundreds of thousands a day, depending on what the component is. and it's wonderful that it's been set up and that this industry was thriving. It's also wonderful that we're seeing smaller companies and newer companies to automation that are looking to apply them to areas of the market where they're needing that flexibility to go to smaller lot sizes. What's also really cool is that there are a lot of companies that are out there, component companies and machine builders alike, that are specializing around small volume, high mix, alternative type manufacturing with using automation, and SCHUNK is one of those companies. So I'll give you an example from an end effector that I was involved in from an end of arm tool standpoint. It was a company that did castings. And so you think about, what a casting company is. It's pretty messy when it comes out of the forming process. There's a ridge where you can see where the molds come together, and on that uneven surface, it has to be ground down. So initially, they were all doing it by hand. They had lines of people with sanders that were grinding this down before they could send it on. The supplier could send it on to their customer. The problem is because they have such a variability of parts, it's hard to set up a machine. And with these types of parts, they're very hard to fixture. You can't just hand it with a robot into a vise. It has to be positioned a certain way. Parts have odd center of gravities, again, high mix. So they have to be positioned in the machine a certain way. They have to be positioned manually. There's really no other way to do it. And so you think about in these CNC machines, having operators bending over a machine table with the door open, that machine not running while they're taking 90 seconds or even a couple minutes per part, getting it clamped down the right way, and then finally shutting the door for a relatively short machine cycle so they can open it up again. And they tried with little success loading and unloading the parts manually because they're constantly had to change over their fixtures, which also took a lot of time. When you change over fixtures, you have to then reprogram and touch off points and do a lot of other things. And what they eventually went with was a clamping system where they could change in and out the work holding very quick in a repeatable way. And also a repeatable end of arm tool that would not load the part directly, but it would load the pallet that was pre-positioned with a part on it. So instead, you would have an operator outside the machine that was staging parts on pallets, and the robot would load the pallets in, and those machines are always running. So they're never stopped. The door opens, pallet with part comes out, new pallet with new part goes in, machine's back and running. So this enabled this company to be so much more productive because they were able to keep that machine up and going, but also have that flexibility when they had the next work piece to the next work piece. They just manually loaded onto another fixture, a fixture that could easily go into the machine, and the machine was ready with its program, for that particular workpiece that was going in.
Okay. Now this kind of goes into our next question as well. When it comes to automating existing equipment and machine tools, what are some of the options that are available out there right now that can help automate what is already out there on the shop floor? Sam, sorry, we'll start with you.
Okay, we'll try to answer a little bit shorter. We are getting close to the top of the hour.
Yes, I'm sorry.
So kind of quickly here, and I'm more in the software life, but coming from the CAD/CAM, and had the opportunity to, when we did the lean manufacturing in one place, the owner said, "Oh, I need a new gun drilling machine because it's a big bottleneck," and he almost about to spend hundreds of thousands of dollars, huge drilling machine. And I said, look into our mapping. Your drilling machine and our map is a big bottleneck, but you don't need to invest hundreds of thousands of dollars. You see that operator entering XYZ by hand, and you replace the controller so you can get digital data. It will cost you $30,000, and you automate it. Your machine is amazing. So the bottom line is you need to look into what you have, again, before you jump and invest millions of dollars in automation. Look into your current assets. By the way, old machines are amazing, sometimes better than new machine, but you have to make sense in the investment. You are not going to put 400 horsepower machine engine in a car that it's from 1960, and the engine will work great, but it will destroy the car. So kind of balance between old retrofit and investment.
And then Tom, over on your end, yeah, what are some things that you have seen out there that can help, automate existing machines on the floor?
I think if I had to pick the single thing that has had the greatest influence in existing machines right now, it's the introduction of cobots into the market. So, oftentimes with cobots, they can be used in a way that's fully automated, where you load a complete process start to finish on an existing machine. Because they're lightweight, they can often be interchanged. So you can set up a machine to run op 10 overnight, come in the next morning, you have a bunch of products that are partially finished, and then the harder step for op 20 can be done manually. Cobots are able to do that to help companies do incremental improvements. At the same time, because they're easy to use and such a large surrounding ecosystems of standardized end effector components and stands and other complementary goods, accessorize cobots easy. A company can get off and up and going and be able to make that transition easier. Even seeing like with companies like SAM, we're seeing companies that do software interfaces that are making all the hardware connect much more easily. So SCHUNK is involved with that too. We do many of our, especially our newer products, are designed so that they plug and play with robots that be able to help that customer on that existing machine be able to get it up and running faster. You think about it, on an app on your phone, you can do so many things now today. Buy an airline ticket, you can go on and do it in 30 seconds. You can shop for a flight, pay for it, and have all the information right there, versus in the past you had 10 steps that you had to do. Because of all that that simplification and all that functionality that are pre-programmed now into the components and supporting hardware for that component. So I would say that that's probably the number one thing that you would look at with for existing machines.
Okay, and then we'll probably end on this one, but what are some of the automation technologies that you see coming in the future that you guys are excited about? Like, what are the things that you could really see taking over as far as automation here in the next coming years? Sam, sorry, we'll start with you.
We're taking from Mark all the time the leading answers. Anyhow, for us, we are looking into what we call Industry 4.0 and all the above or under, because Industry 4.0, to take out all the buzzwords out of this initiative, it's a big automation or big driver for automation. When we talk about Industry 4.0, it's about digital transformation. Here is a buzzword. What do you mean digital transformation? What do you mean by that? So digital transformation, when is associated with artificial intelligence, AI, another buzzword, everything under it is like where the industry should and will go. When we talk about digital transformation, it means that everything that it's currently manual or on paper should be transferred to a digital data. Once it is digitized, that's not enough unless all this data sits in the database. Now, in the database, when you have all the data, which sometimes you call it big data. By the way, I don't see a big difference when people talk about big data. If it's a bank, okay, Bank of America or Citibank, they have big data. It's not about the volume. It's about the data that you own that's stored in a database. So you can be even a job shop when all the data is in the database, then you have a big data. Now, the value of a big data, when you have the layer of artificial intelligence, either in a software or alike, and that means that this artificial intelligence or smart software will analyze the data and it will give you the required information when you need it, not later. Well, no, it's it's too late in the game that you're all, lots scrap or whatever the case. So when you prepare all your downstream preparation, you have everything, the data collection for results in our case, but you have a artificial intelligence that says, oops, based on my AQL, based on my CPK, PPK on SPC, this part is going out of the equation or out of the requirement. I'm going to alert you now before you make another 10,000 pieces and you're going to lose money. You cannot do it if the data or whatever you have is not digitized. You cannot do it if it's not in the database, and you cannot do it if you don't have what we call smart solution or AI intelligence software. So again, the way I see it, it doesn't matter if it's quality, it doesn't matter if it's manufacturing. That's where I see I call it the next generation. And don't be scared on Industry 4.0. Don't be scared from buzzwords. Look into the content, it tells you everything.
Thank you very much, Sam. And then, yes, Tom, what is in the world of automation? What is something that you're looking forward to here in the future?
So in my world of automation, I'm a little more focused into the robot end effector side of things. So I'd like to answer from that perspective, if that's okay. If we back up again towards earlier times when if a company was building an end effector for a robot, somehow it was amazing that they did. Engineers a long time ago, if they were building an end effector, it was almost completely from scratch, and they did it in a practical way. It made money and afforded more and more projects. But they would have to design bearings and pulleys and gears and air pistons or hydraulic cylinders, and all these things would have to get put together to be able to make a robot gripper from scratch. And then companies like SCHUNK and several others came along in the 80s and said, hey, look, we can save you a lot of time. We can produce a standard component that has forces and guidance and packaged in a way that's tested, that's reliable, that is predictable, that you can put this on there and it can save you the first 10 steps. So you can make that end effector quicker. And so what we're seeing today and in the future is another leap forward from that aspect. We're seeing more technologies that are integrated together. So in addition to strong mechanical systems they're pre-engineered to go on robot arms, we're seeing the integration of other technologies, sensing technologies, vision and cameras, software that's tying these things together to be able to make more of a full package. So a good example, sort of like a example from SCHUNK, is that we have a solution where a company that were looking to be able to pick up parts that were not sorted and in a particular order. If they were just sitting on a bench and they were toppled over and all at different angles, that you could be able to take a standard package that had a gripper that was plug and play to a robot that had an integrated camera or easily integrated camera, and decision-making software that can recognize those work pieces, what conditions they're in, so they can tell the robot, how do I move that robot to be able to touch that, engage that part? So, and that can be done on the fly based on the information that's actually pre-programmed into the end effector. And we're just going to be seeing more and more of that, and simplification of it, so it's easier for the user to be able to get their task to be done. And so not only material handling, we see it in fine material removal type applications as well, like sanding, deburring applications, things where parts have different surfaces, and through advanced sensors, force torque sensors integrated into the robot or into the end effector, that you can adapt to changing work pieces and to be able to perform jobs with standardized components, but with diverse applications in standard ways.
Awesome. Well, thank you guys so much for joining us today. and offering some insight when it comes to the automation process. So once again, this is Sam Golan from HIGH QA and also Thomas Reek from SCHUNK. So thank you, gentlemen, once again for joining us today. And also we would like to help and thank our sponsors today, as once again, this was SCHUNK, a worldwide leader for equipping modern manufacturing and robot systems with more than 11,000 standard components. SCHUNK offers the world's largest assortment of gripping systems and clamping technologies from one source. HIGH QA, providers of comprehensive manufacturing quality management system software, and it enables companies of any size, small to enterprise, to automate and integrate their manufacturing and quality processes and even supply chain management. And also THK, for the past 50 years, THK has provided the highest quality motion products and prides itself on offering innovative services in product integration, engineering, and mechatronics to assist customers in bringing their ideas from concept to reality. So once again, gentlemen, thank you very much for joining us today. And we had so much fun. We would also not want to forget our upcoming webinars here at GIE Media, as we have quite a few here on the docket, as we are being joined here soon for the manufacturing lunch and learn, which is coming up here soon on, it is Thursday, February 24th. And then that will be next month, our tool cutting roundtable featuring today's cutting tools advancements. It'll be Wednesday, March 16th. And don't miss out on our Women to Watch in Manufacturing webinar. That is Thursday, March 31st. All of them begin at noon Eastern, and you can register on any of our websites. Thanks once again to Sam and Tom and all of you in the audience. Have a great evening, and we will see you soon.
Thank you very much, everybody.
All right, guys. Thank you very much.